Okay, class. So for today's video, we'll talk about the differential of trigonometric functions. So I have here the formulas for the differential of the six trigonometric function. So before I begin, I just want to clarify a few things here. Suppose for example, if you have, say for example, you have sine u. Okay. Now, the whole of this is what we call the trigonometric function. And the u here, yung u dyan, ang tawag dyan is the argument of the trigonometric function. So this one, the whole of that is the trigonometric function. And your u naman, the u here is the argument. Okay. Now, if your trigonometric function has no argument, then that's not a trigonometric function. Okay? So, a trigonometric function always comes with its argument. Okay? So, amo ito hiya. Now, the value of the argument, notice that I used u, ha? Okay, the value of u there, it could be anything. It could be a polynomial function, or it could be another trigonometric function, or it could be an inverse trigonometric function, or a hyperbolic function. Okay? So, it could be anything. So, for example, your u could be a polynomial function. Then, in that case, you will have sine of x plus 1. Now, the x plus 1 here is the argument of the whole function, of the whole trigonometric function. Okay, and this is a polynomial function. Or it could even be, say for example, cosine of sine x. Yan. Now, your trigonometric function cosine has an argument of another trigonometric function, sine x. Okay, or it could be an inverse trigonometric function. Yung argument niya, pwede inverse trigonometric function. Say, for example, the tangent of, say, arc cosine x. Yan, inverse trigonometric function. Okay, so what I'm trying to emphasize here is that the argument, it could be anything. Okay? It could be any type of function. So, yun yung tawag dyan is argument. And so we have here the different formulas. For the differential of trigonometric function, we have the differential of sine u, and that is equal to cosine u du. Okay, remember that. We also have the cosine u, differential of cosine u, and that is equal to negative sine u du. You remember the negative, ha? Okay? And so on and so forth. I think you can see naman ang mga formula. Now, let me direct your attention here to this second u. Let me erase this first. Okay, suppose you have second squared u. Yan. So, the whole of this is a trigonometric function. Ang u dyan is the argument. Ang 2 here, this 2 here, 2 is the exponent of the whole function, not just the second, ha? It's the exponent of the whole function. So, this is actually equal to second u raised to 2. So, that means if your 2, if the exponent is written just after the second, that means that the whole function is being raised to the power of 2. Okay? So that is equal to the second u raised to 2. Same with any trigonometric function. So for example, if you have tangent cube u, well, this means that the whole trigonometric function is being raised to the power of 3. Okay, so this is equal to this one. Quantity tangent u raised to 3. Okay, and of course, and this is very, don't do this. You cannot distribute 3 here and here. Parang ikasugad mo. Parang masugad. Tangent cube u cube. You cannot do this. This is very wrong. You cannot do that. You cannot distribute the exponent. Lugod, if you have, say for example, cosine u raised to 5, say for example lang, ha, you cannot distribute 5 nga da cosine nga da u. You can only rewrite this as cosine 5u. Yan, ha? Take note of that. And also, if you have, say for example naman, cosine u raised to 2. Now, ang 2, ang power na 2 is only the power of u. That means that u is being raised to 2, not the whole function. Okay? So that means that the argument of the cosine is u squared. Okay? So this is not similar to cosine squared u. That is not equal, huh? Okay. So before we begin, I just want to clarify these things. Okay. So let's have an example. Suppose we have let me get my example. So we'll apply these formulas in finding the derivative of this function. Our function, the given function is y is equal to what's this? X squared sine x. Na masaling ka, "Sir, hindi naman, wala namang formula for this one." 'Di ba? Wala naman diyan. Walang formula diyan, but you know what to do na, 'di ba? Because as you can see, there are two factors. You have your x squared and sine x. So if you are trying to get the derivative of a function with two factors, 'di ba? Ang ginagamit natin um is the product rule. Di ba? If you can still remember, the derivative of u v, di ba? This is equal to the first factor derivative of the second factor plus the second factor derivative of the first factor. I hope you still remember this one. We had this on your differential calculus. So dapat memorize pa niyo up until now. Okay, so if you want to determine the derivative of y, cause derivative gap natin on right side of the equation, and that is x squared sine x. Yan. So there are two factors, this one and that one. Okay, so applying the formula here, we will have the first factor daw, the first factor derivative of the second factor, and that is sine x, plus the second factor sine x derivative of the first factor, and that is x squared. Diba? Oh, masahin lang pag-applyan niya di. Now, the next thing naman, now you can see you have here the derivative of sine x. Oh, this is now the time where you will apply the formula for the differential of trigonometric functions. So you have here copy x squared. The differential of sine x, you have here the formula for the differential of sine. That's equal to cosine u du. Your u is x. So this will be cosine x dx, right? Plus sine x, the derivative of x squared, and that is 2x dx. Yan. Simplifying this further, factoring out dx, so this will be x squared cosine x plus, I'll write 2x first before the sine x. So this will be 2x sine x, and factor out ko ang dx. So this is your final answer. Okay? So this is the value of dy, the derivative of y. Okay, let's have another example. Let me erase this first. Let's have another example. Okay, so we have here example number 2. Suppose we have y is equal to secant x over 1 plus tangent x. You have here 1 plus tangent x. Yan. Okay. So, okay, before we begin, just a tip ha. Before you evaluate the differential or the integral, whatever is the case, before you evaluate the differential and the integral of a function, it is best that you simplify your function first. Okay? Now, for trigonometric function, one way to simplify trigonometric function is by applying the different trigonometric identities. And I hope you know what are those identities. Okay? Because in your trigonometry, gina-admanit niyo it trigonometric identities. So I hope you can still remember what are those different trigonometric identities. Okay, so for this one, I will not apply trigonometric identities here because I have a formula naman for this type of function. This is quotient, diba? We can use the quotient rule, the differential of a quotient. Diba? So if you can still remember, if you have the derivative of u over v, this is equal to the denominator derivative of the numerator minus the numerator derivative of the denominator all over the denominator squared. Yan. So this is the formula that I'm going to use. This is called the quotient rule for differentiation. And you had this in your calculus 1. Okay? So okay, so I will get the derivative of the left side of the equation and also of course the right side of the equation. You have here the derivative of secant x 1 plus tangent x. Yan. Then evaluating the differential using the quotient rule for differentiation. Take note, you have here the your v is 1 plus tangent x and your u is secant x. So you will have 1 plus tangent x derivative of secant x minus secant x derivative of 1 plus tangent x. Yan. All over, oops, parang masubrata yung ano ko, mean division line. All over 1 plus tangent x squared. Yan. Okay, now, as you can see, you have here the differential of secant x, and you also have here the differential of 1 plus tangent x. Now, it involves trigonometric function. Now, this is the time wherein you will apply the differentiation of the different trigonometric functions here. Okay, so this is equal to, you have here, you just copy 1 plus tangent x. So, I'll just copy this one. Now, differential of secant x, you have here the formula for secant x, secant u, that is equal to secant u tangent u du. So, this will be secant x tangent x dx. Yan. Then, you copy secant x, the differential of 1, that is 0, differential of tangent x. You have here the formula for the differential of tangent x, that is secant squared u du. So this will be secant squared x dx. Na. All over 1 plus tangent x squared. Okay. And now simplifying further. Okay, so how do we simplify this one? Now as you can see, wala nang differential dyan except for dx, of course. So we can now proceed to simplifying this. This is now the answer, but we need to simplify this one. Okay, so how do we simplify? Okay, now, as you can see, there are two terms, and each term contains secant x. Let me use another color. Now, on the numerator, there are two terms. This is the first term, and this is the second term. There are two terms, and each term contains secant x, this one and this one. Okay, so we can factor that out. Okay, pwede natin ma-factor ang secant x. So this will be secant x. Then you have 1 plus tangent x. I'll just copy 1 plus tangent x. Then ang mabibilin din is tangent x gihap. You have here tangent x. I'll factor out dx. I'll factor out dx also, but I'll put it on the end of your answer. So this will be minus, we have here secant squared x. Yan. I'll put dx here. So gin-factor out ko ang secant x, kadi ko hansyahan han una, and gin-factor out ko gihap ang dx. Common kasi ang dx gihap pa di man. Kadi ko han orhe. Okay? This is over copy lang the denominator tangent x squared. Yan. Okay. So simplifying this further, so this is equal to secant x. Simplifying this further, getting rid of the parentheses here. So I will use parentheses here instead of bracket. So we have to multiply tangent times 1, that is tangent x. Tangent times tangent, that is tangent squared x. Diba? Tangent squared x minus the secant squared x. Dx, of course. All over the denominator, and that is 1 plus tangent x squared. Now, what can we do? Oh, look here. We have here tangent squared x minus secant squared x. Okay, now we can use trigonometric identities here. We can, diba, trigonometric identity, we have here the secant squared x, and secant squared x, I'll just put it here, ha, for you to, you have here the secant squared x. This is equal to 1 plus tangent squared x. Yes, that's equal to 1 plus tangent squared x. So we can use this identity. O amin takinyayakan nga mga trigonometric identities. So I'll substitute 1 plus tangent squared x to secant squared x to with this one. Okay, so this will be, just put it here, this is equal to, budiong ko, this is secant x, yung copy ko laha, anya di, yung copy ko lang nga di, quantity, you have here tangent x, budiong ko ulit kasurat, plus tangent squared x minus, take note, the value of here, the secant squared x, the value of secant squared x is equal to 1 plus tangent squared x. So I'll put parenthesis 1 plus tangent squared x, parenthesis, close parenthesis, and then pares gapan nga parenthesis, another parenthesis, dx. All over, you have here 1 plus tangent x squared. Simplifying this further, we'll have secant x tangent x plus tangent squared x multiplied the negative to both side, both 1 and tangent squared x. So we'll have minus 1 minus tangent squared x. Yan, dx. All over, of course, the denominator 1 plus tangent x squared. You can cancel this out, diba? Tangent squared x minus tangent squared x, maka-cancel out ini. Ang mabibilin, tangent x minus 1. Okay, so this will be secant x. You have tangent x minus 1 dx all over 1 plus tangent x squared. Yan. Yan. So this will be our final answer for the derivative of secant x. The derivative of this one, of y is equal to secant x all over 1 plus tangent x, is this one. This is our final answer. Okay, so this is how you apply the differential of trigonometric function. It doesn't necessarily mean that you will automatically use the formula. Okay, you still have to use the power rule, the product rule, the different the different differential different rule for differentiation. Anyways, okay, so I hope you memorize these different formulas for differential of trigonometric function, because on your practice exercise 1.3, I will give you a function. You will get the integral of that function, and those functions will involve trigonometric functions. Okay, so memorize the different trigonometric function. Differential of the different memorize the differential of the different trigonometric functions.